Hey, what's going on, guys? CodeMonkeyGames here. In this video we're going to be implementing positional score evaluation within our evaluation function. And once I've written a chess engine called Nibble Chess, which is obfuscated chess program, and I used a single array positional score encoding there. I would say even more. In this particular chess engine, I used the word array to encode both the position and the evaluation scores, believe it or not, because I was trying to make the source code really tiny here. So the entire source code for this sort of an engine takes only for about 500 lines. And you see like many print statements here, so it would be even less. So you see like variable names don't really say much and so on, but it uses very interesting logic of defining of actually calculating this positional scores. And if you just have a look at the evaluate position function right over in here, you see like positional score is added in case if it's white to move, and also it's kind of subtracted in case if black to move actually, and the index is calculated like the board index plus 8, but we won't obviously be using this part because we will have a separate array for this. But this sort of a scores, it took me quite a bit of time. This scores on the right, it took me quite a bit of time in order to provide the reasonable numbers. And the interesting thing behind this is like you could have specified the number of positional scores equal to the number of pieces, like every single piece would have its own positional scores. But from the practical perspective, there is no much difference in the style of play with those for those engines that actually have this positional score tables for all the pieces, or just one table for all the pieces. So we would be using this only array here. So I just want to grab this entire stuff. I'll get rid from the board position, obviously. Just wanted to mention the source where I'm taking this positional scores from, because I'm not going to be writing them by hand, it takes too long. And we can just go to the current version of our source code, and let's put it somewhere near the board. So yeah, canceling writes, well, let's say somewhere over in here, so I can say like positional scores. Okay, and I create the array of integers called positional scores. So I guess I call this material score. Yeah, and let's call this one positional score. And obviously the length of this array would be 128 elements, just like we usually have. And I just paste this stuff in. So I want to get rid of the board position, obviously, so I would be using only the scores here, and the right part of the board would be replaced with the of board value as always. Okay, so let's give it a little indentation here. Okay, and I just want to copy and paste. Like this. Okay, so I hope it still compiles and runs. So let's open the terminal in the current working directory. Okay, and by simply typing make, I will compile the source, and if it compiles, it would produce the binary executable called chess hexadecimal 88 that I will run then. Okay, so it still compiles, it's perfect. It gives us a better score for whites because we did get rid of a couple of pieces for the black. We'll restore that just right in a moment. And yeah, let's actually go scroll down a bit here. So the very first thing to consider, so rook, knight, and here the pawn. So first, I just want to restore the position. Yeah, I just want to restore the position for my pieces. Okay, so now I get the score of 0. I just was thinking like how to distinguish white and black pieces in this case, because in the previous engine that was the matter of the only single bitwise end operation, but that was possible because the piece encoding was done in a specific way. Well, it probably, so let me think how I'm supposed to be doing this time. So in general, we need to either use the positives, to use this positional scores, like score would be kind of plus equals in case if we're dealing with the white pieces, and in case if we're dealing with the black pieces, we need to subtract. So probably we need just to distinguish. So if piece is white, in this case, so yeah, like if, and I'll use the code that has been already used within the move generator, so I can say if piece is greater equals than 1 and piece was less equals than 6. So where are these digits are coming from? Let me just show you this one more time. So this comes from the piece encoding. So we have the 0 for the empty square, then we have this 1, 2, 3, 4, 5, 6. So greater equals than 1, less equals than 6, and greater equals than 7, and less equals than 12 for the black pieces actually. So yeah, here we match the white pieces, and in this case we need to say score plus equals, and now we are referencing the positional score array indexed by the square. Yeah, indexed by the square. But hold on a sec. Hold on a sec. I just wanted. I just need to check one little thing here. Well, yeah, it seems like so. Anyway, we'll just test this out. And else if, and we have piece less equal greater equals than 7 and piece less equals than 12. So this is the case with the black pieces. Okay. Yeah, we'll just check this. Yeah, I don't really remember this by heart because it was quite a bit too long time ago. It was a long time ago. I didn't do this for quite a bit of time, so just need to recall my memory slightly a bit. So here we should do like score minus equals and positional score indexed by the square. So yeah, so we would be evaluating every single piece. Okay, so now we'll start testing this, and this would clearly show like how it works. If it works correctly, obviously. If not, yeah. So I'm also a bit wondering. So this works only if piece. Yeah, so only for pieces basically. If it's an empty square, it's not gonna fire really. Well, okay, so as far as the position is equal for both score and material, it should give the evaluation equal to 0 still. Okay, and if say now we move our pawn from e2 to e4, well, I'm not going to be encoding move and using the make full move function. Instead, I'll just it's literally enough to just, okay, so A, B, C, D, E, and so A, B, C, D, so 4, pawn, 3, and now it should give a positive score for white pieces, because white pieces have their E pawn on a better square compared to the black pieces. And I will now try to calculate in mind like what exactly the evaluation is supposed to be. So A, B, C, D, E, 2, E4. So it should give the evaluation like plus 30. And again, like you might wonder where these numbers are coming from. So you see, like, that 30 is definitely less than 100, which is the evaluation for the kind of material equivalent of 1 pawn. And we evaluate the positional advantages like less than the material advantages, obviously. So it's kind of like what? So 30 is what part of? So if this was 50, this was a half a pawn, and this, it's almost like third part of a pawn. So the placing the pawn on this square is valuable like the third part of the pawn. And obviously, like all this evaluation scores are obtained via trial and error methods. So you just try to play around with them and until they become optimal, basically. But the core idea is that we gave the most score for the center if the pieces are located in the center, and then the further it comes away from the center, the last position becomes. And also we provide this minus this kind of minus score for a king square, and this 5s here for the places where king can castle. So this this kind of scores actually forcing a king of a given site for castling. So it's forcing him to castle as soon as possible. And obviously there might be way more complicated logic of achieving this goal, but as far as this is the beginner's chess programming engine, chess engine tutorial, I'm trying to make things as easy as possible. So just the most trivial ways of achieving these sort of goals. Okay, so it should give us plus 30. I really hope so. Let's see. Yeah, perfect. Oh my god, but just I did put this slightly a bit too much, but this is still 30. Yeah, so I'm sorry. So I just yeah, pawn can't go that far. For pawn like this, it still should be 30. Okay, and on E2 or on E3, it should give us 20, because there was kind of 20. Okay, so if we just now move say E7 to E5, so it would add 30 to black, or kind of this would subtract 30 from the overall score, and eventually the score after E7 and E5, it should be equal to 10 actually. So let's try this. So if I just try like A, B, C, D, E pawn, just like this, and here 4 empty squares, then the black pawn and 3 empty squares. Okay, minus 10. But why is this minus 10? Oh yeah, obviously this is minus 10. Yeah, not plus 10, this is minus 10. Yeah, and if we just bring this pawn back to kind of E4, it should be equal to 0 again. So just grab this and put it right over in here. This should be the equal position. Yeah, because the positional scores are kind of mirrored there. So this is it basically, and it seems like our positional evaluation works well. If it doesn't, we'll see actually when we would be testing our chess engine while playing it versus its own self, which is quite pretty entertaining, I must say. So if something goes wrong, we'll definitely see this. So I will leave this evaluation function for now like just as is, and probably already starting from the next video we're gonna be implementing our search function, Enigmax search function. So this is it from my side within this video, guys. I hope you learned something interesting out of this tutorial. So thanks for watching, until the next time, and take care.